find all the possible combinations of the two numbers. So they've given the LCM. Is 1188 and the HCF is 9. So we don't know the two numbers. Let's say let the two numbers be X and Y. Okay. Let's take a few minutes to solve it. If you have solved it, you can share your answer in the chat with me. Okay. Does anyone have any questions about what the problem is?
Good evening, ma'am.
Good evening, Aithreya. So I just posted the first question. The LCM and HCF is given, and we have to find all possible combinations, all the possible combinations of the two numbers. All right.
Ma'am, we need to do this sum.
Yeah. Who is this?
Ma'am, you are yes, ma'am. Start doing it. Did you start doing anything or
Yes, Agne, what is it?
did you start doing something or you
Yeah.
have?
Can you see the problem that I posted?
Yes, ma'am. Oh, okay. Ma'am, I send my answer.
Yeah. Ahan, can you check the second number? Is that a typo?
Ma'am, is my answer right?
Achyutan, I think yes, correct.
Right.
Achyutan, can you check your second answer? The second pair that you have given, can you check that?
Ma'am, you're saying like from the two numbers I've given, my second number is wrong?
Yes, the second option that you have given, Achyutan.
No, I'm saying Ahan, ma'am.
Ahan. Ahan, the numbers 20, the second number that you have typed, can you check that?
Yes, let me check.
You want 2 more minutes to try the problem before we start solving?
Yes, ma'am.
Okay.
Ma'am, I think my answer is right, ma'am.
Achyutan, okay.
Ma'am,
Ahan, is it?
ma'am, Achyutan.
Achyutan, okay. Hold on. You're almost there, yes? When we will discuss the problem, yes? Agnay, can you check again? Agnay, think about it this way. The numbers that you have given as solution, is there LCM 1188? Okay, let's start solving. Okay,
Can you wait a second?
okay. Yeah, Achudan, yes. I think you can get one more pair, Achudan. Okay, we'll discuss it because then we won't have time for other problems. Okay. Achudan, do you want to share how you did it?
Yes, ma'am.
Okay.
Ma'am, first, what did I do was a product of any two numbers is equal to the LCM into HCM.
Okay. So you are
So
saying
I
x into y is equal to
equal
9
to
into.
1180.
Okay.
And ma'am, then I found the answer is 10,692.
Okay. 10,692. Okay. 9. Is this the?
So in order,
Okay. Okay.
ma'am, yes, ma'am.
Okay.
Uh,
Okay. Okay. Hmm.
Ma'am, so in order to find all the combinations,
Hmm.
I prime factorized 10,692
Okay.
and I got 10,692 as 3 to the power 5 into 2 square into 11.
3 to the power of?
5 into 2 square into 11.
Okay. Okay.
Ma'am, I sent my answer, but I've got only 13 pairs. Actually, there should be 18. So actually, I was finding them, but then I didn't have time. So is that correct?
Um.
I've sent the first 13 pairs.
Yeah. So I'm just looking at it, Darsh. So for example, if I look at the pair which says 11 and 972, is 9 the HCF for that pair? Or for 3 and 3,564? Is 9 the HCF?
Yes, ma'am, I think so.
For 3 and 3,564, is 9 a factor of 3?
Oh no, it's not a factor of 3.
Yeah. So can you try again?
Okay, okay.
Okay. I mean, some of the answers, some of the pairs are right. So you just have to eliminate the ones that are not okay. Hmm? Okay. Yes. Achudan, go ahead.
Yeah, ma'am. So in order to have a number with HCF 9, the number should be at least minimum 3 power 2 into something
Yeah.
or above.
So X should have definitely 3 square as one of the factors, X and Y. Okay.
Yes, ma'am.
Okay.
So in order for that to happen,
Mhm.
we have so first all the numbers that I considered by doing this method were 9 and 1188 from the first one.
Okay.
Next, then I got 18 and 594,
Okay.
27 and 396.
So how did you get 594? You just
Ma'am, first
divided,
9 into 2 is 18. We are multiplying this by 2 and we are dividing this by 2.
so you divided the LCM by 18, is it?
Ma'am, no, ma'am, I didn't do that. Just in the simple way, I just multiplied 9 by 2 and I divided 1188 by 2. That's
Okay. Okay. You just progressively went from here.
yeah.
Okay.
And then 27 and 396,
Okay.
36, 297,
Okay.
81 and 132. Ma'am, but if we notice, we see that 81 and 132, their HCF is not 9.
Yes.
So we can cross that out.
Okay.
The same way for 18 and 594, since 18 and 594 both are divisible by 2 as well as by 9. So
Yeah. So
the
HCF
HCF
is
becomes
not
80. So that is also crossed
exactly.
out.
Yeah. So that's not okay.
These are the three questions.
Okay. But did you have to do this prime factorization for this?
Yeah,
Does
ma'am.
this help you?
Yeah, ma'am.
Because even 9 is a factor, isn't it? So
Ma'am,
you started from 9 and 1188 and you just went from there. So did you have, how did this help you? This factorizing 10,692.
ma'am, for example, ma'am, I think I just prime factorization.
Okay.
Yeah,
Okay.
ma'am, I think I think I might have used extra power. I might have gone to extra powers. So in order to check the limit of the power
Okay.
cycle.
Okay. 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 That makes sense. Okay. All right. So here is what I did. Does anyone else have any other method?
Ma'am, how did we get 9,1188 and all those pairs?
Achudan, you want to explain again?
Ma'am, I didn't understand the
So he's asking you, how did you start with 9,1188?
ma'am, because the 9 into 1188 is nothing but 10692, and there is no this is the greatest factor. Ma'am.
So the way it works, Dash, is suppose 9 is the HCF, isn't it? So I can say the number X is some multiple of 9. Yes, 9 times, say, let's say A. Okay. And 9 is a factor of Y also. So Y is also some multiple of 9. Is everybody okay with this?
Yes, ma'am.
Okay. Then it says LCM of the two numbers is 1188. So LCM, if I want to find the LCM of X and Y, I have to write the common factors once, isn't it? So 9 and 9 is a common factor. So I'll write it once. And then I'll just copy the remaining factors A into B, which is nothing but 1188. Does this make sense?
Yes, ma'am.
Yeah, because HCF is the common factor. X and Y have only one common factor, which is 9. So we have to write 9 only once. A and B are co-prime to each other. That means there are no common factors between A and B. So we have to write A and B as it is. And when you multiply all three, you get 1188. Now, if I divide by 9 on both sides, I get A into B is 9 ones are 9, 9 threes are 27, 9 twos are 18. So I get A and B is 132. Now, if I factorize 132,
You get 11 2 into 2.
yeah. So what are the different pairs that I would get for 132? I'll get 1 taken 132 times, 2 taken 66 times, then 3 taken 44 times, 4 taken 33 times, then 5 will not work, 6 taken 22 times, and then 7, 8, 9 will not work. Then we have 11 taken 12 times. So these are the possible combinations of A and B. But we know this is the most crucial factor, that A and B are co-prime to each other. They don't have any common factors between them. So when I look at A and B, 1 and 132 are co-prime. So I can use this. 2 and 66, are they co-prime to each other?
No.
They have a common factor of 2, isn't it? 66 is 2 into 33. So 2 and 2 are common. So I cannot use this. 3 and 44 are
They are
co-prime
co-prime.
to each other. I can use this. 4 and 33 are co-prime to each other. I can use this. 6 and 22,
They are not co-prime.
they are not co-prime. I can't use this. 11 and 12 are co-prime to each other. So I can use this. So that is why Achyutan eliminated 18 and 594. Because they are not co-prime. So their HCF changes. They have another common factor between them in addition to 9. 9 and 2. Then their HCF becomes 18. But our problem says HCF is 9. So we have to eliminate all the numbers which are not co-prime to each other. Now if I substitute my values for A and B, 9 into 1 and 9 into 132, that is one possible pair. That is 9 and 1188. Yes, then I can substitute 9 into 3 and 9 into 44. 9 into 3, 27. 9 fours are 36. 9 fours are 36 plus 3, 396. So this is one pair. Then I can take 9 into 4 and 9 into 33. 9 fours are 36. 9 threes are 27. 27, 297. And then one last pair I have. 9 into 11. 9 into 12. 9 11s are 99. 9 12s are. So there are 4 possible pairs whose HCF is 9 and whose LCM is 1188.
I have them.
Okay.
Ma'am, why you wrote like A and B are co-prime?
Yeah. So if X is 9 into A, because 9 is a HCF of A, isn't it? So X
Yes,
is 9 is a factor of X and Y is some 9 into B. Because 9 is the HCF of Y. So Y is some multiple of 9 into B. Now, if I have to find the LCM of X and Y, how do I write LCM?
ma'am, by prime factorization.
Sorry, Abhinav, can you say that again?
Ma'am, by prime factorization.
By prime factorization, we have to write the common factors once, isn't it?
Yes,
What is a common factor?
ma'am, 9 and 9.
9. There are no other common factors.
Yes.
Because HCF, the very definition of HCF is it has all the common factors of X and Y. So we have written all the common factors. So whatever is remaining, the remaining factors, they must be not common with each other. They have to be co-prime.
Yes.
So for example, if I take 15, 15 is what? 3 into 5. And let's say 18. 3 into 2
6.
into
23.
okay. So what is the common factor between 15 and 18?
Ma'am, 3.
3. If I eliminate that, whatever is remaining, 5 and 6, they are co-prime to each other, isn't it?
Yes. Yes.
So that will help me eliminate all the eliminate the choices that are not right. Even though I have 6 pairs, 1, 2, 3, 4, 5, 6, I eliminate the ones that are not co-prime. Okay.
Ma'am,
Yes, Agne.
can you repeat the definition of the co-prime?
Yeah. Co-primes are numbers. They are, sorry, Abhinav, can you mute yourself? So co-primes are numbers, Agne, which are not prime by themselves, but with respect to each other, they are prime. So they don't have a common factor between them. For example, 5 and 6. Yes, do they have any common factors between them?
No, ma'am.
So, or I can have 15 and 16. Yes.
Oh, okay.
3. Yes, this is 2 into 2 into 2 into 8, 2 into 4. 15 is not a prime number and 16 is not a prime number. But when I look at them as a pair, with respect to each other, they are co-prime. They don't have a, relatively, they don't have a factor common between them.
Okay, ma'am.
Okay. Shall we go to the next problem?
Yes, ma'am.
This is a very interesting problem. Oops, sorry. Let me just type the letters. It's A, J, H. Yes. Yeah. Mhm. And the digits 1, 9, 8, and 9. Okay. Let me explain the problem. So there are letters A, J, H, S, M, E and digits 1, 9, 8 and 9. They are written together. They are written in a cyclical order. So if I start with, for example, J, H, S, M, E, A. This is some order I'm starting with. Okay. The next time I would start from H. That would be my first one. I'll write H, S, M, E, A, then J. And here I would start from 8. So I'd write 8, 9, 1, and 9. Okay. Now the next one, I would start from S. So I'll write S, and whatever comes after that, I'll write it S, M, E, A, J, H. And this one, I would start from 9. 9, 1, 9, 8. And it goes on like this. So they are asking, the first time I wrote this, it was like this. A, J, H, S, M, E. Their question is, when will this pattern of A, J, H, S, M, E 1989 appear for the first time?
Ma'am, what do you mean by first time?
So as I keep writing this in a cycled order. Yes, so let's say this is the one iteration, this is the second iteration, this is the third iteration. At which iteration will this appear? They're asking.
Okay.
Okay. Let's give work for 2 minutes silently. So this AJHSME and 1989, they should appear together in the same line. Okay.
Ma'am, is my answer correct? Skandan.
Okay, let me check. Shivansh, you are right. Skandan, can you try again?
Center second answer, is that correct?
Yeah, I'm looking at the second answer only. Harish, can you try again? Johan, correct? No, Johan, try again. Agnay, right? Oh, I'm sorry, I confused the answers. Agnay, can you try again? Agnay and Samrit? Shivansh, you are right.
Ma'am and Sabrit, is my answer correct now?
1 second, Samrit, let me see. Samrit, is it the second answer or the first answer? Harish, can you try again? Samrit, is yours the first answer or the second answer? Which one should I consider?
Sorry, ma'am.
You have sent me two answers, no? Samrit, which one? The second one is right. Harish, yes. Achudan, yes. Correct. Nidhi, can you try again? Shamika, can you try again?
Ma'am,
Yes, Abhinav.
ma'am, that AJHSME and 1989. So after at which time it will come, will you write down?
After how many iterations will they appear together again?
Yes.
Shamika, can you try again? Okay, since many of you have answered, I'll go ahead and discuss the solution. Who wants to share their solution?
Ma'am, can I?
Agnay? Okay.
So can I start?
Yeah, go ahead.
So the thing is that in the letters AJ has HSME.
Okay.
Every 6 times it starts with A. So
Okay.
it goes on by 666.
So let me write what you are saying. So if we keep cycling this, I'll have M, E, A,
J,
J, H, yes. And then
you go with E,
I go E,
A,
A,
J,
H,
H,
yes,
S.
M, and
Next
then
one starts with A.
A, A,
J,
J, H, S, M, E. So it takes 1, 2, 3, 4, 5, 6. Sixth time for AJHSME to repeat. Okay, then
so every 6 times AJH.
yeah,
And
okay.
for because there are 4 digits,
Mm-hmm.
it will take every 4 times 1981 comes.
Yeah. So the fourth iteration. This is
So basically, we find the LCM of 6 and 4.
okay.
Sorry. Yeah, so it will be 12.
Yeah.
And yeah, so 12th time.
Yeah. So
My answer is actually wrong because it's the second time it will come. So my answer,
24, is it?
yeah, ma'am.
Yeah. So did everyone understand what Agnesh shared? Any questions about
Ma'am, why did you take the LCM?
so the AJHSME repeats every 6 times. So this will appear the 6th time, then it will appear in the 12th iteration, then it will appear in the 18th iteration, and so on. Yes. So 1989 appears on the 4th iteration, then on the 8th iteration, and then on the 12th iteration, then on the 16th iteration, and so on. So which iteration is common between them?
12.
12. That is why we took the
The
LCM.
answer is 12.
Yeah, answer is 12. So they will repeat 12, 24, 36, isn't it?
All multiples of 12.
Yes. Is it clear, Dash?
Yes, ma'am, it's clear.
Okay. Aitreya, you have a question? Your hand signal is raised. Do you have a question? Okay, so based on this concept, let me give a problem. So this week, the full moon occurred on a Friday. After how many days will the full moon again occur on a Friday? I can give a hint. Full moon occurs every, say, 30 days.
Mom, I think it's 28 days.
Yeah, let's, for our problem solving purposes, we just take that. Okay. The number doesn't matter. The method in which we have to solve this problem is what we are interested in. Yes.
Ma'am, I have sent my answer.
Ma'am, you are muted.
Ma'am, I sent my answer.
Ma'am, I sent my answer. Is my answer correct?
Ma'am, you're
You're
on mute.
on mute. You're on mute.
Sorry, guys. I think I was talking. Let me go through it. Let me answer again. Johan, correct.
Answer correct.
Hold on. Amit, correct. Johan, correct. Samrit, try again. Abhinav, try again. Achudan, correct. Darsh, correct. Shivansh, correct. Aitreya, correct.
Okay.
Naga, try again. Samrit, try again. Viraj, correct. Agnay, correct. Okay, since so many of you have answered, I will discuss the solution so that we can discuss more problems. Skandan, correct. Raga, correct. So it is basically just like the previous problem, isn't it? The full moon repeats every 30 days. So the full moon occurs. So this is the full moon. It occurs on the 30th day, 60th day, 90th day, 120th day, and so on. And how often does Friday repeat?
Ma'am, can I
7 days.
tell how? Ma'am,
7.
can I tell how?
Yes, Aitreya.
Ma'am, as Friday occurs every 7 days, like
Yes.
weekly there will be one Friday. So we should find the LCM of 30 and 7 because we have to find the day in which Friday is also common and full moon is also common.
Yes. Yes. And 30 and 7 are co-prime. So multiplying them will get us the LCM. Okay.
Ma'am, and the full moon will occur in every multiple of 210.
Yes. Yes. On a Friday.
I'm getting calculation error.
Yes. Okay. Let me share the next problem.
Ma'am,
Yes. Somebody had a question? Okay. So let's look at the problem. Two farmers agree that pigs are worth $300 and that goats are worth $210. When one farmer owes the other money, he pays the debt in pigs or goats, with change received in the form of goats or pigs as necessary. That means if he has to pay 390 rupees, he can pay it with two pigs. So 390 rupees, one pig is worth $300. So he's paying actually 600, isn't it? So that is, so 600 minus 390 is 210. So the return 210 is nothing but the goat. So instead of money, they are exchanging pigs and goats like this. What is the amount? What is the amount of smallest positive debt that can be resolved in this way?
Ma'am, I didn't understand the smallest positive debt. What is that?
So they are exchanging money with each other, isn't it? 300, 210, like this. So what is the smallest way the money that can be exchanged between them? What is the smallest money that amount of money that can be exchanged between them in this fashion? So if I have to pay 390 rupees, I paid it this way, right?
Ma'am, with change or without change?
With change. With change or without change, doesn't matter. What is the smallest amount? So the example they have given is he paid 300 to pigs. And what did he get? Isn't it? 290, is it? Let me check.
Ma'am, I sent my answer.
Okay. That's correct. Aitreya, can you try again?
Yeah.
Ma'am,
Ma'am, is my answer correct?
Okay, hold on, let me check. Agnay, can you try again? Shivansh, correct? Viraj, can you try again? Aitreya, can you try again?
ma'am,
Yes, Abhinav.
ma'am, this we pay when we pay the smallest amount, then we need to get this two goats and pigs on it.
Then we need to get
Ma'am, we need to get pigs and goat. One pig, one goat on it.
I'm sorry, Abhinav. I'm not able to understand what you're saying.
I don't understand the last line.
Last. So that is why I've written this equation. So what they want is, what did he do? The example they have given is he has to, this money, 390, he has to pay. And how did he pay this 390 rupees? He paid it by giving 2 pigs and he got 1 goat in return. So they are asking, this 390, can you make it as small as possible? What is the smallest amount of money that can be exchanged this way? They want to reduce this 390 to the smallest.
Ma'am,
Yes, Aitreya.
ma'am, why can't it be 90? Because if somebody wants to pay a debt of 90 rupees, so one farmer can give 300 rupees worth pig and he can get in return one goat, right?
I'm not saying your answer is wrong, Aitreya. It is right, but there is a amount that is smaller than 90 possible, because they are asking for the smallest possible positive debt. You are right. 90 is can be exchanged this manner. So all Aitreya is suggesting it is I give 300. So bam, it's 90. Yes. So can we go lower than 90? So Kavin, can you try again? Achudan, correct? Agnay, can you try again? It's lower than 90. Nidhi, correct? Agnay, try again. Viraj, yes, there is some kind of change. Samrit, try again. Johan, correct?
Ma'am, you need to get change or?
There will be change, isn't it? Because the amount is smaller than that is exchange between them is less than even 90. So how can it be without change? Because even if he pays a single pig, he owes 300, or somebody owes a goat, it is 300 or 210. But I'm saying the number is smaller than that.
Miss,
So
hello,
that will change.
hello, Miss Saket here.
Okay.
Miss, I reached home late. I was coming from outside. Miss,
Okay.
what just happened? Just roughly, what happened?
So the problem that we are discussing now is on the screen. It's a two farmers agree that pigs are worth $300 and goats are worth $210. So when they want to pay each other money, they pay their money in terms of pigs or goats. And when one farmer owes the other money, he pays the debt in pigs or goats with change received in the form of goats or pigs as necessary. So if he wants to pay 390 rupees to the other farmer, he can pay in terms because he has only pigs, he gives two pigs. So that is 300 into 2. So he has given extra money, isn't it? So that is owed to him. So the money he'll return get back is a goat in change. So that way they resolve a debt of 390 rupees. So this debt that they resolve, what is the smallest possible amount is the question.
Ma'am, I said my answer again.
Ma'am, smallest possible amount for which? What for which amount of debt?
The smallest amount of money that can be exchanged hands in this manner.
Okay.
Samrit, correct. Aitreya, try again. Harish, try again. Okay, here, let's see. Let's discuss the solution. Who wants to share their solution? Can I see a show of hands?
Can I share?
Darsh, okay, go ahead.
So I basically use Buset's theorem, or
Yeah.
like
Yes.
there is a theorem that says that the GCD is the smallest linear combination of the two numbers. So that means basically you have to find the GCD of 300 and 210. So that will be the smallest linear combination. So the GCD is 30 and hence answer
Yes.
will be 30. And you
Yes.
can find the X and Y using Euclidean algorithm.
Yes.
That-
We'll do our next problem will be that. So what Darsh is saying is, he used Bezout's theorem, which Tambe sir introduced this to us, isn't it? And in our previous class, we also discussed what is a linear combination. That's why to give you all a clue, I wrote it in a linear combination. So this equation is a linear combination. So the way they exchange goats and pigs is, I can write it as a linear equation. I can write it as some number of pigs and some number of goats. So when I write the numbers in such a linear combination, Bezout's theorem says the smallest possible number here will be the GCD or the divisor. So this will be the GCD. So all you have to do is find the GCD of 300 and 210, which is nothing but 30. Yes?
Miss,
Anyone
I
have
have a
any
question.
Yes, Saket.
Miss, does this Bezout's theorem apply, like, for example, for any common factor? Like, for example, 300x plus 210y is equal to any common factor of 300 and 210?
I'm not sure I follow your question.
Like, for example, let's say like any like common factor like 2. In this example, I don't think that there is any possible way of a common factor like for example 2 or 5 being exchanged this way. So that does not exist a linear combination of positive
Yeah,
integers.
so to answer your question, let's do the next problem. Yes? Hold on. How do we find all the Bezout identities? Okay. So this is our next question. So what does this mean? Find the Bezout identity for A is equal to 710 and B is equal to 310. That means I can write them in a linear combination. 710 and 310, I can write it as a linear combination. I can write 710 into some x plus 310 into some y is equal to its GCD. Yes. What is the GCD of 710 and 310? Can somebody tell me?
Ma'am, 10.
10.
Yes. So what are the possible values for x and y? That's what the question means. What values of x and y should I substitute such that I get 10 there?
Closest to 0 possible combination, because it will be difficult if we have to find the smallest compare.
So Darsh gave a clue already that we have to do the Euclidean algorithm backwards. Sorry.
What is this 710x plus 310y equal to 10?
This is the Bezout theorem that Tambe sir discussed, isn't it? So if you have two numbers, let's say
And
3.
how can we add 3-digit numbers and get 2-digit numbers?
So they are integers. So x and y are integers. Okay. So we have to do Euclidean algorithm. If if you don't remember Euclidean algorithm, I will start doing it here. We have to divide the biggest of the two numbers by the smallest number. Okay. So I have 710. I have to divide it by 310.
Ma'am, I sent my answer.
Yeah.
Ma'am, what do you mean do it backwards? Euclidean algorithm backwards.
Yeah, that's what we are going to discuss, Saket. Darsh can help. 1 second, Darsh. Let me check your answer.
X and Y means they are being multiplied or being.
Sorry, Vijay, what is the question?
Ma'am, X and Y are there, no ma'am? They are being multiplied or they're a part of the.
710 into x
Okay.
and 310 into y.
Okay.
Darsh, I think there's a small correction to yours. You're almost there. The second number, 310 into, can you check that?
Ma'am, was my answer correct?
You didn't hear me?
No.
Sorry. The 710, the x value is right. Are you getting 10 when can you check? I think you're getting 20. I mean, 320.
Okay. So if we solve that,
You're
that
there.
value
You're
will be
almost-
20.
Yeah, you're almost there. I think you have to check your second number, I think.
Okay, okay.
So this is the Euclidean algorithm. Yes. Does anyone have any questions about the algorithm? You have to divide the biggest number by the smallest number, and then you have to use the remainder and divide the previous divisor. You have to keep dividing till you get answer remainder 0. So that divisor which gives you remainder 0 is the GCD of the two numbers. Any questions?
I'm just 2 minutes, ma'am. I'm almost done.
Okay.
Find out Ma'am,
Yes, Agni?
so we do the this algorithm for finding out the GCD of two numbers.
Yes.
What is it called, ma'am?
Bezout's theorem. Sir, Tambe sir did it in the class. He said he's a French mathematician. It is pronounced Bezout.
Yeah, ma'am.
Yeah.
Ma'am. Oh, yeah, okay.
Ma'am, I've resent my second
Yeah.
Y value.
Yeah. Correct.
Okay.
Okay. Does anyone have any questions about the Euclidean algorithm to find GCD?
No, ma'am.
No.
Okay. So you may not know, many of you, how to work it backwards. Darsh, can you tell me what you did? I can write it on the screen, how you worked it backwards.
Yes, ma'am. So I first wrote it in equation form.
Tell me.
So
So,
it's
Just 1
7.
second, Darsh, hold on. So what we are trying to do is, we are going to work backwards like this, starting from 10. And we are going to try and write it in the same format. 710 into something plus 310 into something, we want to get 10. So we are going to start at 10 and work our way backwards and try and get the same equation again. Okay? Yes, Darsh, go ahead.
So if you write it in the equation form, we
Mhm.
get 710 equal to 310 into 2 plus 90
710.
equal to 310 into 2 plus 90. I'm basically writing the Euclidean algorithm in equation.
Yeah, okay, all right. So he's writing the first one. So 710 is nothing but 2 times 310 plus 90.
Plus 90.
Hold on, Darsh. Does anyone have any questions about this first step? Is everybody clear why we have written it this way? This is nothing but quotient plus remainder, isn't it? Dividend A is equal to QX plus R.
Miss DQ, because we use the divisor like.
Okay. Yes?
Ma'am, why did you do 2 into 310?
So this is from here, Agnay. It is from here.
So you multiply.
When I finish the division, I can write 710 is nothing but 310 taken 2 times plus the remainder 90. Is that okay?
Okay, ma'am.
Yeah, basically the division, we have written it as a equation. Okay?
ma'am.
Is everybody clear? Okay. Darsh, can you tell me the next step?
Yeah, so then it becomes 310 equal to 90 into 3 plus 40.
So now we are going to write this one as an equation. So I'm going to write 310 is equal to 3 times 90 plus 40. Okay, go ahead.
90 equal to 40 into 2 plus 10.
Then we are going to write this one. 90 is equal to 2 into 40 plus 10. Okay.
And then 40 equal to 10 into 4 plus 0. So then 10 will be the GCD.
Yeah. 40 is equal to 4 into 10
Plus
plus
0.
Okay. So whatever we did, we have written it like an equation. Okay. What to do
So
next?
now we start from the second last equation and we
Okay.
get 10 equal to 90 minus 2 into 40.
So that says we have to start from this equation here, because we want to rewrite this equation. We take this one, we are interested in the 10. So I can rewrite this as 10 is equal to 90 minus 2 into 40. Okay. Any questions for this step? Okay, go ahead, Dash.
Now we can substitute from the third last equation 40 equal to 310 minus 3 into 90. Can
Okay.
substitute the value of 40 in
So
our
this for 40, I'm going to substitute from this equation. Yes. So I'm going to write most of it as it is. I'm going to write 10 is equal to 90, the same. The 2 is also the same. But for 40 alone, I'm going to rewrite it as 310 minus 3 into 90. Okay. Any questions? Okay, let's go ahead.
So now we can open the bracket. We will get 90 minus 2 into 310 plus 6 into 90. Now if we take 90 and it's 6 into 90 actually.
Oh, sorry, 2 into 3, yes.
So now if we take 90 and 6 into 90, it will become 7 into 90
Yeah,
minus 2
we
into 3.
can group this and we can group this. So this is nothing but 7 into 90 minus 2 into 310. Okay, okay. Next.
Now we can substitute the value of 90
Huh.
from our first equation.
So instead of 90, I can write it from the first equation. I can write it as 7 as it remains as it is. I can write it as 710 minus 2 into 310 minus 2 into 310.
Now if we open the brackets, we will get 7 into 710 minus 14 into 310 minus 2 into 310. So if we group it, we will get minus 16 into 310.
So if I group these two, I get 7 into 710 minus 16 into 310, which is nothing
So
but equal
basically
to,
we have got our x and y, 7
Yeah.
and minus 16.
so this is nothing but, this is the same as this one here. This is nothing but 710 into x plus 310 into y is equal to 10. So if you compare these two, hold on, Saket. If you compare these two, you know 710 into 7 plus 310 into minus 16 is equal to 10. So the Bezout identity x is 7, y is minus 16. Okay. Any questions? So you have to work out the Euclidean algorithm, and then you have to work backwards. Yes.
Ma'am,
Yes, Saket.
can you give a similar problem to this so we can just work it out and see whether we are getting the correct answer, because there was a lot of steps in this.
Yeah, this needs to be practiced, isn't it? If you make even like I did a mistake here, isn't it? I didn't multiply the 2 and 3, and then everything goes for a toss. So you need practice. Maybe I can give it as homework. Yeah. Now we'll try a different problem if nobody has any questions. Yes.
Can you go up a little?
Yes, Agnay. Here.
Yes, ma'am.
Hmm.
Yes, ma'am. Done.
The whiteboard will be shared. Don't worry about it. You can take a look at it later. Yeah.
Oh, okay, ma'am.
So in the Google Classroom, the recording and the whiteboard is pasted, isn't it? I mean, posted. So let me choose another problem. Does anyone have any questions? Shall we do that problem which Tambe sir gave? This one, did anyone found a way to prove this? Let me share it.
Did we discuss homework problem today?
No, we didn't. So this one, this was given by Tambe sir, isn't it?
And can Saket answer, ma'am?
Ma'am, I've done this problem.
Hold on. Let's give 2 minutes for everyone to try if they have not tried it.
Ma'am, what do you mean by R14N plus 3?
So this is one number, 21n plus 4. It's a fraction, Agne.
Oh, okay.
So let me write it like this. It is 21n plus 4 by 14n plus 3. Can you show that this is irreducible?
Ma'am, I copy pasted my explanation from the homework.
Saket, I'm looking at it.
Actually, ma'am, it's literally clumped up together. Let me just take a screenshot and upload it.
It's okay, Saket. I'm able to read it. Don't worry about it. Yeah, that makes sense. Saket, what you have written makes sense. Yeah. Can I share the answer? If we do that, then we'll be able to do one more problem. Otherwise, we'll run out of time.
Ma'am,
Or
I'm
did
telling
you
you
want
the
to try?
ma'am, can you just give me 2 minutes?
Yes, Sachidan. Okay. That's what I was asking. If you want to try, go ahead.
And what is meant by irreducible?
Irreducible means you cannot reduce it any further. Like suppose if you have a fraction 15 by 25. Yes, can you reduce this fraction? Yeah. So you can say it is 3 by 5. Can you reduce 3 by 5? So 3 by 5 is the irreducible form. So can you show that this is not, you cannot reduce it further?
Yes.
For any number n, there is no number. Okay. You just equated the numbers, isn't it, Achudan? What if there is a multiple of that, if that exists? Aithreya, yes?
Can I explain it after some time?
You want to share? Okay, go ahead. Did you share your answer?
No, ma'am.
Okay, you want to explain? Okay, go ahead.
Ma'am, actually, in this fraction, we can just ignore the n for some time. Ma'am, we noticed that 21 and 4 are co-prime numbers and 14 and 13 are co-prime numbers. 14 and 3, sorry.
14 and 3 are co-prime.
21 and 4 are also co-prime.
Okay.
Anything multiple of the co-prime can't be reduced into a fraction. So this is irreducible form of the number.
So these both are co-prime to each other, you are saying, isn't it?
Yes.
But we want to prove that these both are co-prime to each other.
Oh.
Okay.
Numerator terms can also not
In
be
case, ma'am, in this case, it is 25 n and it is 17 n. So 25 and 17 are co-prime to each other.
But for all n's, this is for n is equal to 1. But for all n's, can you prove that?
Saket?
Yes, ma'am.
Yes, Saket, go ahead.
Okay. So, ma'am, okay. So, this question, as you said, simplifies to that numerator and denominator should be co-prime, or basically HCF should be 1.
Yes.
So
So
now,
GCD or HCF of 21n plus 4 and 14n plus 3 should be 1 because they are co-prime to each other. Okay.
yes, miss. Wait, miss, that is square brackets. You have to put.
Oh, sorry. Okay. Okay. Thank you.
Yes, miss. So now let D equal to the GCF of 21n plus 4 and 14n plus 3. You can just write next to the 1, you can put it. Okay.
Yeah. Okay. Let D be the GCD. Okay.
Yeah. So now because now by the definition of a GCD, D has to divide 21n plus 4.
Yeah.
And D also has to divide 21n plus 3. No, 14n plus 3, sorry.
Okay, no worries.
14n plus 3. So this also means that that D divides 21n plus 4 minus 14n plus 3. So
Your combination, isn't it?
yes, miss. And also, like, you in Euclid algorithm, you can find the difference of these two. So it'll obviously have to be, because if
Yeah.
okay. So now with this, you can subtract 14n plus 3 and 7n plus 1. You get 7n plus 2.
Hmm.
So now
Plus 1.
no, miss plus 2.
4 minus 3, no?
No, 14n plus 3 minus 21. Wait, no, ma'am, 14n plus 3 minus 7n plus 1. No, sorry. What I meant was D has to divide the difference of 14n plus 3 and 7n plus. Yeah, okay, yeah, this is the first step. Sorry, I'm getting confused. Okay, yeah. So from here, we can say that D divides 14n plus 3
Okay.
minus 7n plus 1, because we just saw that D divides 7n plus 1.
Okay.
14n plus 3 minus 7n plus 7n plus 1. Now you subtract both of them. 7n plus 2. So now using both of these, we can say that two consecutive numbers are always coprime, except when it is 0 and 1. And it's said for every positive integer n. So we are sure that, so because of D dividing 7n plus
Contradiction, isn't it? D divides 7n plus 1 and 7n plus 2 consecutive numbers, that it is
Yeah.
not
And
possible.
7n plus 1 and 7 plus 2, 7n plus 2 are co-prime. So the only possible D would be 1.
Yeah.
Because
Ma'am, can I give another proof?
Yes. Yes. Darsh, go ahead.
So basically, if we use the Euclidean algorithm to find the GCD, we'll
Mhm.
get 21n plus 4 is 14n plus 3 into 1 plus 7n plus 1.
21n plus 4 is 14n plus 3 into?
Into 1 plus
Okay.
7n plus
7n plus 1. Okay.
1. Now if we write 14n plus 3 equal to 7n plus 1 into 2 plus 1. So now we will get 7n plus 1 is equal to 1 times 7n plus 1 plus 0, basically. So basically that means that 1 is the GCD of 21n plus 4 and 14n plus 3. And if 1 is the GCD, that means that the fraction has to be irreducible.
Yes. I also have another way, just what I wanted to share.
Ma'am,
So,
can I also share my
yes, 1 second. So if it is 21n plus 4 by 14n plus 3, I can write it as 2a. If I multiply both numerator and denominator, then I can write it as 42n plus 8. Yes, and I can write it as 42n plus 9. Then they are consecutive numbers, isn't it? If they are consecutive numbers, they won't get divisible. Somebody else had a proof? We are running out of time. Quickly, we'll run through that. Who had a
Ma'am, so you multiplied the numerator by 2 and the denominator by 3.
that I can't do, isn't it?
Then how did you get?
72. Wait. How do I get 42?
Multiply by 2.
Multiplied by 2. No, I did something wrong.
ma'am, what you did was correct only. Usually,
Uh,
if the multiple of two numbers are not co-prime, then the original numbers may or may not be co-prime. But if the multiples itself are not are co-prime, then the original numbers will definitely be co-prime.
Yes. So this is 7 into 2 into n plus 3. Yes, so this is 7 into 3 into n.
We can do that. We can
If I rearrange this, if I rearrange this, so this is 7 into 3, this is 7 into 2. Yes. So if I try to make it common across by introducing a factor, then this will be 42n plus 8 by 42n plus 9. Now, does that make sense?
I didn't get, how did you get 42n plus 9?
So I'm trying to make this the same, equivalent.
Okay, but for that you have to multiply the numerator by 2 and then divide by 3, right?
But it just shows that they are co-prime to each other, isn't it? That they are consecutive numbers.
Okay.
They're not okay. I'm not trying to make them equivalent fractions. Yes.
Oh, okay.
Somebody else had a proof?
Ma'am, Achudan.
Yes, Achudan.
Ma'am, if we try to equalize both the numerator and denominator such that they equal 1, we will get that 21n is equal to 14n minus 1, and there is no such number n. And there is no such
So you
number.
are saying equalize the numerator and denominator.
If yeah, ma'am.
If
Then we get that 14n minus 1 is equal to 21n, or 21n plus 1 is equal to 14n, and there is no such number like that, because obviously always 21n is always greater than 14n.
But why do you want to equalize them?
Ma'am, I'm also going to say the next step. Ma'am, if we want to equalize, or either if the numbers that were added to this were either uh, multiples of 7, or if they were equal, then it would be possible to reduce it, but in this case they are not.
Yeah, can't equalize them, isn't it? Okay, so we are running out of time. We have to stop here.
And what does subtracting have to do with saying about any common factors? I didn't understand.
Yeah, that's okay. So Achudan, I think, is saying if the numbers were equal, then no such number exists. And the multiple is also not possible, he's saying.
Yeah.
Okay.
So this shows that 21n plus 4 and 14n plus 3 can never be equal.
So that's what he's also saying, that they are not equal. No such number exists is what he's saying. And a multiple also does not exist is what he's trying to say. Okay, so we will stop here. This is the last class of LCM and HCF. The next class, the topic will be different. But the class is again on Sunday. I hope you had fun doing LCM and HCF problems. I know yesterday's class was a bit challenging, but please try them again. And if you have any questions, you can ask them in the Google Classroom and I'll try and answer them. Yes. The recording at the whiteboard will be posted in the Google Classroom. Okay. Thank you.